Hello student, how are you? I am Arun sir. Welcome to my channel Tuition Expert. Today in this class, I will teach you the basic equation of motion of a straight line, which is class 11 physics. This class will specially help for class 11 students and also student of NEET. Students, if you follow my class attentively and watch my video regularly, then I can assure you that you crack the IIT exam and NEET exam confidently with a good rank. Now let's start about the class. General method. Suppose a body or a particle moves with velocity u. That is, initial velocity of the particle is u at t equal to 0. Now after t second, the velocity of the particle is v. So what is the acceleration of the body? This is the proof of v equal to u plus at. Acceleration of the body, we know rate of change of velocity, that is v minus u by t. So the motion of the body is along straight line. So just we subtract this. This is not a vector. We are not using the vector convention. So acceleration equal to v minus u by t. From this we get v equal to u plus at. Simple equation. Now second equation, s equal to ut plus half at square. Second equation, this, prove this. So t equal to 0, particle starts with velocity u. After t second, the velocity is v. The distance travel is s in time t. The distance travel is s in time t. So what is the velocity? Velocity equal to u plus at, final velocity. Now what is the distance travel? Distance travel equal to, we know, constant velocity into time, but here velocity changes. Velocity is here u, here other value, and final velocity is v. That is, velocity changes. Here velocity changes and body moves with uniform acceleration. A equal to uniform acceleration. That is, body moves with uniform acceleration. Now what is the distance? Distance here will be average. If velocity changes, then we have to consider a constant velocity, which is average. We can assume that average things is constant. Average velocity into time. Average velocity, that is this velocity, average velocity, may be assumed that it is constant throughout this motion. This velocity is constant throughout the motion, but actual velocity changes. But if we take the average velocity, then it is constant throughout the motion. Then average velocity means two value, u and v. So u plus v by 2 into time, that is v equal to so this is equal to ut plus half at square. So this formula is proved. This square equal to, now we get v equal to u plus at. This is equation 1, and s equal to ut plus half at square, equation 2. Now in this equation there is no t, so we have to eliminate the t. That is, from here we get t equal to v minus u by a, and put the t at here, in here and here. So from 2 we get s equal to u into t, v minus u by a plus half a into t square, that is v minus u by a whole square, which is equal to a square. Here is a square, cancel 1a. Now 2a, so which is equal to, cancel this and this, that is this is u square minus v square. So we get v square equal to u square plus 2s from this equation. From this, cross multiply this, and yes, what is essence? Essence means distance covered in nth second. What is nth second? Nth second means suppose a body moves from this place to this place in time n seconds. That is total time taken to goes from A to B is n second. Now what is nth second? Nth second means last 1 second. Last 1 second is called last 1 second is nth second. Last 1 second is called nth second. So what is the distance traveled in last 1 second? Now for this we have to calculate Sn. Sn means distance traveled in n second, and S, suppose this is C, suppose this is B, last 1 second. Time taken from A to goes from A to B is n second. So this is Sn, and this is Sn minus 1, that is the distance traveled in n minus 1 second. So obviously Sn means distance traveled in last 1 second, which is equal to Sn minus S minus 1. So Sn equal to Un plus half a n square minus this equal to so this here what is A is uniform acceleration. Now this is equal to Un plus half n square minus this equal to Un minus u plus half a n square minus 2n plus 1. So cancel Un half. So now this is equal to Un plus half n square minus Un plus u minus a by 2 n square minus 2n plus 1, which is equal to cancel Un and this, and half n square plus u minus half n square plus a by 2 2n minus a by 2. So this also cancel this and this, last we get u plus take common u by 2 2n minus 1. So this is the distance travel in nth second, means distance travel in last 1 second. Distance travel in last 1 second. So these are the general graphical method. So we know proof of this. This is velocity, this is time. This is u. T equal to 0 here. Suppose this is O, this point is A, this point is B. This is velocity, time graph. This is meter per second, this is second. We draw a velocity time graph of a particle. The particle starts with initial velocity u, and motion is acceleration, uniform acceleration. Motion is uniform acceleration, and initial velocity is u. So the graph of the particle will be this straight line. Now what is the theory? Theory is that we know the slope of vt graph, velocity time graph, equal to acceleration of the particle. This is the theory. We know the slope of vt graph, velocity time graph, equal to acceleration. So this is the straight line. This straight line. Now draw here. this, suppose this is BC, this is D. Now what is the slope of the line? This angle is theta, so this is actually theta makes an angle with this line, means the theta makes an angle also with this line, that is time axis. This is theta, so slope of line AB, equal to what? Tan theta. We know slope equal to tan theta. So tan theta from the triangle ABC. What is tan theta? From the triangle ABC, tan theta equal to perpendicular by base. Now what is perpendicular? Perpendicular BC equal to V minus U. Suppose velocity is here V. So V minus U, because U here, this is V, and this is U. So BC equal to V minus U, and AC is along time axis, so AC get T. So tan theta, slope of line equal to tan theta, which is equal to V minus U by T. Now we know slope of the line is acceleration, so acceleration equal to V minus U by T, that is V equal to U plus AT. This is the proof. Here theory used is that the slope of any line in VT graph equal to acceleration. Slope of VT graph equal to acceleration. This theory is used here. Second proof. We draw the same figure. Suppose this is velocity, this is time. We draw the same figure. Suppose this is 0, A, this point is B, draw a perpendicular, this is C, this line, this is D. Now this angle is theta, so slope of the line is theta. Now this is T, so this is T, U is this, and V is this. From this to this is V. Now what is the theory here? We know area under VT graph, velocity time graph equal to distance traveled. We know area under velocity time graph equal to distance traveled. So if we calculate the area of this, then we can calculate the distance traveled. So S equal to area of OABC. This is a quadrilateral which is trapezium, because this side and this side is parallel, so this is a trapezium. Now area of this quadrilateral can be taken as this rectangle plus this triangle. So this is area of ABD plus area of OABC, or we can take the area of the trapezium as a whole. We can take the area of the trapezium as a whole, and so area of ABD equal to ABD half base into altitude BD. What is BD? BD equal to V minus U. What is BD? BD equal to V minus U, because this is V, this is U, so this is V minus U. So this, and plus area of OADC is velocity length into breadth, which is U into T. This is T, this is U. So this. So what becomes? So this is now we know slope of AB equal to acceleration A. So slope of AB equal to tan theta. which is equal to perpendicular by base v minus u by t. This is equal to a, so v minus u equal to at. Now put v minus equal to at here, so we get s equal to t by 2 into at plus ut, that is ut plus half at square. So this is the proof. Now what is b square? Similarly, we know distance travel equal to s equal to area of OA B C, which is equal to trapezium u plus v into height. Here height is this is t, and two sides u and v, two parallel sides here u and v. So half of sum of two parallel sides into height or distance between two parallel sides. Here distance between two parallel sides is t this, and two sides, two parallel sides u and v. This is v, this is u. So this now what is time taken? T. We know a equal to v minus u by t. We know t equal to v minus u by t. That is t equal to v minus u by a. T equal to v minus u by a. So this is equal to v square minus u square by 2a. Okay, v square minus u square by 2a. S. So s equal so v square. Yes, this is the proof of. This is the proof. So this is this. Slope of AB. Slope of AB, that is v minus u. This is v minus u, perpendicular by base v minus u. Slope of AB equal to acceleration, so a equal to v minus u by t. From this we get, now put t is at here, then we get this. This is time, this is velocity. So the area, this area denotes this area. This area is the distance traveled in last 1 second. If this n second, this is n second, and this is n minus 1 second. So this last 1 second is this. Last 1 second is this. Now we have to calculate this area. So this area, we know area of, suppose this is BC D AB OA BC D, suppose this is E. Now this is U, initial velocity U, this. So area of CD EB equal to distance travel in nth second. Last 1 second is this. So this. Now area CD EB equal to area of OA BC minus area of OA ED. This area to, if we subtract whole area to this area, then we can get this area. So area of OA BC now equal to, similar formula, half sum of two parallel sides u plus v into n. Here height is n, and we know acceleration equal to v minus u by n. Here we take time is as n. This plus and area of OA ED equal to half u plus, suppose this is v and this is v dashed. Suppose this is v dashed. So this u plus v dashed into time is here height is n minus 1, n minus 1. Now u plus, so here acceleration we get e equal to v dash minus u by n minus 1. Now put here half u plus v into n. From this n we get n equal to v minus u by a, and u plus v dash into n minus 1. What is n minus 1? N minus 1 equal to v dash minus u by a. Now from this v equal to u plus a n, and from this we get v dash equal to u plus a n minus 1, So put u plus b, v equal to u plus a n into n minus half u plus v dash equal to this u plus a into n minus 1 into n minus 1. So if we calculate, if we simplify, then we get this result. Now what is the simplification? Simplification is half so if we minus un plus u, if we multiply this into this, and minus an, so first u 2u by 2, that is u into n plus half a n square, minus here we get minus u minus un minus u minus un plus u, and this equal to n minus a minus half into n minus n. So if we this and this cancel, so this half n square plus u minus half of a n square minus n plus a n square minus n plus a by 2, which is equal to minus 2n by 2 minus, so we cancel this and this, we get the result u plus a by 2 2n minus 1, u plus take common a by 2, so n minus 1. So this is the result. So result is this. This is the proof of in graphical method, all the formula. Now next calculus, calculus method. Now we know acceleration equal to dv by dt. This is the calculus formula. Acceleration equal to dv by dt, and distance travel equal to dx by dt, and velocity equal to ds by dt or dx by dt. Here s and x both denotes distance travel. Now a equal to dv by dt, motion in a straight line, distance and displacement are same. Motion in a straight line, distance and displacement is same. Uniform one direction motion. Uniform we consider, if we consider one direction motion along straight line, then distance and displacement same. distance and displacement same, unidirection, one direction. If direction be reversed, then distance and displacement may be changed. But if we consider the one direction and along the straight line, here displacement and displacement remain same. So we consider displacement or distance travel, anything. Acceleration equal to dv by dt and velocity equal to ds by dt, we know. So here initial velocity is u, initial velocity equal to u, and final velocity v. So by calculus method, dv equal to a equal to this, dv equal to a dt. A is constant. Now if we integrate this, then t for t equal to 0, velocity is initial velocity. Initial velocity means when t equal to 0, final velocity at t, final time t, so final velocity here. So when time 0, when time 0, then velocity is u. When time t, then velocity is v here. Okay, we put here like this way. So dv, integration of dv is v, u, v, and a is constant. So a outside, we take a as we take a outside, and dt integration is t. Dt integration is t. So this becomes v minus u equal to at, that is v equal to u plus at. This is the proof of first. U plus at, we have proved v equal to u plus at. Now v equal to ds by dt, at, ds equal to u plus at into dt, integrate both sides. Now put t equal to 0, s equal to 0, and at t distance is s. So integration of ds is s, 0 to s here, u dt so this is upper limit minus lower limit. We put s as upper limit minus lower limit, u into dt, integration of dt is t, plus a into t1 means t square by 2. So t square equal to this by calculus method. We know acceleration equal to dv by dt, and also we can write this as this way. Just adjusting ds here, here and here. We adjust ds here and here. So now ds by dt is v. So now ds by dt is v. So a equal to v into dv by ds. So this is the another formula. A equal to v dv by ds. This is the another formula of acceleration. Now a into ds equal to v dv. Integrate both sides. We know initial velocity when s equal to 0. When s equal to 0, velocity equal to u, actually initial velocity. Now when ds equal to 0, then velocity is u. When s, velocity is v. So here a ds integration s, v dv means v to the power 1. So v 1 plus 1 by 1 plus 1 uv. Okay, now a into s equal to v square by 2 half v square minus u square, which is equal to this. So v square equal to v square plus 2s. By calculus, this is true. Student, this is the end of the class. To get more such type of video, subscribe my channel. Okay, thank you.